cat's purr, so cations are positive and anions are negative. And that's how I want you to remember the charges of these ions for electrolysis when it comes up tomorrow in your Chem Paper 1. And remember that cations always go to the cathode and the anions always go to the anode. They always pair up. So if the cations, which are positive, go to the cathode must be negative because opposites attract. Same with the anions, which are negative, they go to the anode, so the anode is positive, attracting the negative anions because, again, opposites attract. I also want you to remember that electrolysis is splitting up lysis molecules through electricity, and it's a DC current that we use. Now, when we're dealing with molten substances, only those ions will be present. So if we've got molten sodium chloride, the only ions that would be present in that substance would be sodium ions, Na+, and chloride ions, Cl-. But if you see the word solutions in your question tomorrow, solutions mean that that substance is dissolved in water. So yes, we'll have sodium and chloride ions, but because it's dissolved in water, we'll also have hydrogen ions and hydroxide ions. And these positive and negative ions are competing to see which one will get to be at the cathode and at the anode. Now at the anode, it's never going to be the hydroxide ions that win. It's always going to be the other negative ion, the other anion. So in this case, it would be chloride that goes to the anode and it forms chlorine gas at that anode. Whereas for the cathode, you have to think a little bit more. And it's this that you have to remember, the reactivity series, which you can remember by remembering, please stop calling me a careless zebra, instead try learning how copper saves gold. And that should help you remember this list from most reactive to least reactive. So again, in that case of sodium chloride, we can see that sodium is more reactive than hydrogen, which is all the way down here. And it's the least reactive cation that's going to win, the one that's going to react at the cathode. And in this case, it's hydrogen. Hydrogen was lowest in that reactivity series, so that's the one that goes to the cathode. That's the one that forms hydrogen gas. Now let's go back to the molten example where the only things that were present in the substance were sodium and chlorine. If we were to write half equations for that, we'd have sodium plus an electron, because sodium is a positive ion, a cat ion, plus an electron, which will neutralize that positive charge to form just sodium, solid. And at the anode, we have two chloride negative ions, making chlorine plus 2 electrons. Because they were negative, they're going to form 2 electrons in the products. And the chloride gas is what we're going to see bubbling at the anode. If it was a solution, then of course we'd have to write half equations for hydrogen plus ions forming hydrogen at the cathode, and for Cl- ions forming chlorine at the anode. Like I said, easy.